Hello everyone. Today we will going to see some practice questions from the chapter P block elements. This is part 5. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. So this is our index slide. We will going to see the practice questions from question number 36 to question number 44. Let's start with the question number 36. The structure of XeO3 is. So we have to tell the structure of XeO3 compound. Options are linear, planar, pyramidal, or T-shaped. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option C, that is pyramidal. So if you look at the electron pairs present in the XeO3 molecule, the total electron pairs is 4 times 3 bond pair plus 1 lone pair. Okay, so it is sp3 hybridized and it is having a pyramidal shape. You can see here, this is the shape for XeO3 having 1 lone pair and 3 bond pairs. Okay, basically total electron pair is 4, includes 3 bond pair and 1 lone pair. Okay, you can see this in this diagram. That's why it is having sp3 hybridization and the shape will be pyramidal shape for the sp3 hybridization compounds. And thus option C, that is pyramidal, is the correct answer. Okay, let's move to the next question. Question number 37. XeF4 and XeF6 are expected to be. Options are oxidizing, reducing, unreactive, or strongly basic. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is oxidizing. So XeF4 oxidizes potassium iodide. If you react XeF4 with the 4 iodide ions, it will give us 2I2 plus 4F minus plus Xe. So you can see that the XeF4 oxidized the potassium iodide. Basically it is Ki, so we just write it K positive, I negative, so we write I negative only. Okay, so here also it comes Kf, okay, and I2. In the I2, the oxidation state of iodine will be 0, and in I negative the oxidation state will be minus 1. As you can see, minus 1 charge is present in the iodine. So you can see the oxidation state is increasing. That's why the XeF4 oxidizing the potassium iodide and itself get reduced, and XeF6 oxidizes hydrogen like other xenon fluorides. XeF6 oxidizes hydrogen like other xenon fluorides. Means XeF6 compound oxidizes hydrogen if it is present in the reaction. If hydrogen and XeF6 are present in the reaction in a combined form in a reactant side, then XeF6 oxidize hydrogen as like any other xenon fluoride do. Okay, if any xenon fluoride exist, they also oxidize hydrogen, and XeF4 oxidize potassium iodide. You can see the reaction here, and thus A option, that is oxidizing, is the correct answer. Okay, Let's move to the next question. Question number 38. Which of the following acids possesses oxidizing, reducing, and complex forming properties? So we have given some acids in the options. We have to tell which acid possesses oxidizing, reducing, and complex forming properties in it. All three of them. Options are hydrochloric acid, HNO2, sulfuric acid, or HNO3. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option B, that is HNO2. So HNO2 is an acid, possesses oxidizing, reducing, and complex forming properties, as in it oxidation number of nitrogen is found to be +1. Oh, +3, right? And the +3 oxidation state of nitrogen in HNO2 lies in between -3 to +5. It can exhibit -3 oxidation state to +5 oxidation state, and +3 is in the middle of these range. That means it can gain electron. So it can act as reducing agent, it can act as oxidizing agent. Okay, it can gain electron, it can lose electron, and it can also form the complex. And that's why HNO2 is an acid which possesses all these three types of properties mentioned in the question: oxidizing, reducing, and complex forming properties, due to the oxidation state of or oxidation number of nitrogen present in the HNO2, which is +3. Okay, thus option B, that is HNO2, is the correct answer. Okay, let's move on to the next question. Question number 39. Match the species given in column 1 with the properties given in column 2. So we have a table here in which we have two columns, column 1 and column 2. In the column 1, we have some species like diborane, gallium, borax, aluminosilicate, and quartz. In the column 2, some properties are given, like used as a flux for soldering metals, crystalline form of silica, banana bond, low melting, high boiling, useful for measuring high temperatures, used as catalyst in petrochemical industries. So these are some properties given in the column 2. Now what we have to do, we have to match the column 1 to the column 2. That means species with their respective properties. Options are: A is for 3, B is for 4, C is for 1, D is for 5, E is for 2. A is for 4, B is for 3, C for 1, D for 5, E for 2. Or A for 4, B for 3, C for 5, D for 2, and E for 1. Or A for 1, B for 2, C for 5, D for 4, or E for 3. You have to solve this question. You have 10 seconds, and after that we will see the answer. Okay, let's see. The correct answer is option A. A is for 3, B is for 4, C is for 1, D is for 5, and E is for 2. So in the first A, it has BH3 is unstable, forms diborane B2H6 by 3 center 2 electron bond, show banana bond. Okay, that's why A is related to 3. B, gallium with low melting point and high boiling points makes it useful to measure high temperatures. Yeah, that's why B is related to fourth one. In the C, borax is used as a flux for soldering metals for heat, scratch resistance coating in earthenwares. Okay, that is why C is related to the 1. D, aluminosilicate used as catalyst in petrochemical industries. That's why D is related to the fifth point. And for the E, quartz is a crystalline form of silica. That's why E is related to the second property. Okay, thus our option A is the correct answer. Okay, let's move to the next question. Question number 40. Directions. Each of these questions contains two statements, statement 1 and statement 2. Each of these questions also has 4 alternative choices, only one of which is correct answer. You have to select one of the codes A, B, C or D given below. The statement first is boron always forms covalent bonds. Statement 2, the small size of boron 3 positive favors the formation of covalent bond. Options are statement 1 is true, statement 2 is true, statement 2 is a correct explanation for statement 1. Statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1. Statement 1 is true, statement 2 is false, or both the statement first and second are false. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option B, that is statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1. So boron always form covalent bond. It is a fact. It is because boron requires very high energy to form boron 3 positive, and again boron 3 positive, due to its very small size, have high polarizing power, thus cause greater polarization and eventually significant covalent characteristics. Okay, this is the Fazan's rule, and this is the statement which clarifies statement 1 and statement 2 both, and thus option B, that is statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1, is the correct answer. Okay, let's move to the next question. Question number 41. Again, each of these questions contain two statements, statement 1 and 2, and we have 4 choices, from which only one is correct, so we have to select the one. Statement 1 is, in water, orthoboric acid behave as a weak monobasic acid. Statement 2, in water, orthoboric acid acts as a proton donor. Options are statement 1 is true, statement 2 is true, statement 2 is correct explanation for statement 1. Statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1. Statement 1 is true, statement 2 is false, or both the statement 1 and 2 are false. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option A, that is statement 1 is true, statement 2 is true, and statement 2 is the correct explanation for the statement 1. So in water, orthoboric acid behaves as a weak monobasic Lewis acid. Okay, and Lewis acid is which can donate the protons. You can see here we have orthoboric acid, BOH whole thrice, right? One molecule of water attacks to the boron at the center, and it will form a bond with the oxygen, and positive sign will come on the oxygen, negative sign will come on the boron, and then it will form this complex which is BOH whole 4 negative H positive. Okay, so in the water, orthoboric acid behaves as a weak monobasic acid, and in water orthobaric acid act as a proton donor. Both the statements are true and the statement 2 is correct explanation for statement 1. Thus our A option is the correct answer. Okay, let's move on to the next question. Question number 42. Statement 1 is between SiCl4 and CCl4 only SiCl4 reacts with water. Statement 2, SiCl4 is ionic and CCl4 is covalent. Options are statement 1 is true, statement 2 is true, statement 2 is a correct explanation for statement 1. Statement 1 is true, statement 2 is true, statement 2 is not a correct explanation for statement 1. Statement 1 is true, statement 2 is false, or both the statement first and second are false. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. So the correct answer is option C, that is statement 1 is true and statement 2 is false. Statement 1 is between SiCl4 and CCl4 only SiCl4 reacts with water. This is the true statement. But SiCl4 is ionic and CCl4 is covalent. This is not the correct statement. And hence, statement 1 is true, but statement 2 is false. SiCl4 is also covalent, bonded. Okay, this is the correct form of statement 2. Thus, our C option is the correct answer. Okay, let's move on to the next question. Question number 43. Direction. In the following questions, assertion and followed by the region is given. Choose the correct answer out of the following choices. Assertion A is silicons are water repelling in nature. Reason: silicons are organosilicon polymers which have R2SiO as repeating unit. Options are assertion and region both are correct statements and region is correct explanation of assertion. Assertion and region both are correct statements, but reason is not the correct explanation of assertion. Assertion is correct and region is incorrect. Or both assertion and region are incorrect. So you have 10 seconds to solve this question. After that, we will see the answer. Let's see. The answer is option A, that is assertion and region both are correct and region is correct explanation of assertion. Silicons are a group of organosilicon polymer which have R2SiO as a repeating unit. This is correct. So reason is correct. This suggests that silicons are surrounded by non-polar alkyl groups. You can see R is a alkyl group here that are water repelling in nature. They have wide applications. It is used for waterproofing of fabrics. Okay, so assertion is also correct statement that silicons are water repelling in nature. Okay, and thus our A option is the correct answer, that assertion and region both are correct statements and region is the correct explanation for the given assertion. Okay, let's move to the next question. Question number 44. Assertion is nitrogen and oxygen are the main components in the atmosphere, but these do not react to form oxides of nitrogen. Region: the reaction between nitrogen and oxygen requires high temperature. Options are assertion and region both are correct statements and region is correct explanation of assertion. Assertion and region both are correct statements but reason is not the correct explanation of assertion. Assertion is correct and reason is incorrect. Or both assertion and region are incorrect. You have 10 seconds to solve this question. After that, we will see the answer. Okay, let's see. The correct answer is option A, that is assertion and reason both are correct statements, and reason is the correct explanation of assertion. So, nitrogen is an inert gas because of the presence of strong bond, having smaller size and strong bond. That's why, although there is 78% nitrogen in the atmosphere, but nitrogen oxide is not formed under ordinary conditions. But when the temperature is high enough, let's suppose 2000 Kelvin, it reacts with oxygen to form nitrogen oxide at such condition. Like we have to increase the temperature about 2000 Kelvin. Then it can form nitrogen oxide after reacting with oxygen. You can see the reaction N2 plus O2 at 2000 Kelvin equivalent temperature, giving us 2NO, that is nitrogen oxide. Okay, and thus the assertion and reason are true, and reason is correct explanation of assertion. Okay, and thus the option A is the correct answer. Okay, thank you.